Hey space explorers, and welcome back to Cosmic Chronicler. We're your guides through the awe-inspiring, sometimes bewildering, always fascinating universe. Today, prepare to have your cosmic understanding shaken as we dive into some truly astonishing revelations coming from the edge of space and time itself. What if everything we thought we knew about the birth of our universe was just wrong? Seriously, what if the dawn of creation wasn't some slow, gentle awakening but an absolutely explosive, wild era? An age of cosmic giants forging galaxies at a speed that just blows our minds? For decades we've had this picture of a universe gradually putting itself together. But now, the James Webb Space Telescope is sending back images that are tearing up that old script, revealing secrets that are not just jaw-dropping, they're history rewriting. So for a long time, our cosmic story started pretty calmly. After the Big Bang, the universe was this dark, foggy place, mostly a huge cloud of hydrogen and helium. The prevailing wisdom, what scientists called the standard model of cosmology, told us that the first stars and galaxies would be tiny, faint, and would take ages to bubble up from this primordial soup. We imagined this slow, careful process of gravity doing its work, with little proto-galaxies gradually merging and growing over hundreds of millions, maybe even billions of years. Think of it like a cosmic garden, right? Seeds slowly sprouting into little saplings before they eventually became the huge forests of galaxies we see today. This whole model was built on years of observations, super smart computer simulations, and our best understanding of physics. It predicted a universe where the really massive, well-formed galaxies were late bloomers, showing up much later in the cosmic timeline. The early universe, everyone believed, was just too young, too unformed, to host anything but the most basic structures. It was a universe taking its sweet time, a quiet little flicker before the real fireworks. That was the story in all the textbooks. But what if those first chapters were way more dramatic? And then came the James Webb Space Telescope, or JWST for short. Launched at the end of 2021, this thing isn't just another telescope, it's practically a time machine. With its gigantic segmented mirror and incredible infrared vision, JWST was designed with one seriously audacious goal: to look back to the very dawn of time, to see the first stars and galaxies being born. Its instruments were built to catch the faint, ancient light that has traveled for over 13 billion years to reach us, light that's been stretched into infrared wavelengths by the expansion of the universe itself. Previous telescopes, even the amazing Hubble, could only really get a peek at the universe's teenage years. They hinted that there was stuff out there in the early days, but they just didn't have the muscle to see it clearly or push further back into those cosmic dark ages. JWST, though, it's about 100 times more sensitive in the infrared than anything before it. It promised to lift that veil. Scientists were pumped, eagerly waiting for it to confirm their theories, expecting to find a universe slowly, methodically blinking into existence. What they found instead? Well, it was a cosmic revolution. The JWST wasn't just looking at the early universe, it was forcing us to completely rethink its baby years. Almost as soon as JWST opened its golden eyes, the universe it started showing us was not what we expected. Instead of faint, tiny baby galaxies, it started finding these unexpectedly bright, massive, and pretty well put together galaxies lurking in the cosmic dawn, way earlier than any model said they should be. And this wasn't just a one-off, it was happening again and again. One of the most mind-blowing examples is a galaxy called JADES MOMz14. Early in 2024, observations confirmed it exists at a redshift of 14.32. Now what that means is we're seeing it as it was less than 300 million years after the Big Bang, when the universe was just a toddler, barely 2% of its current age. And JADES MOMz14 isn't some faint little smudge. It's surprisingly bright and big for that early in the game, measuring over 1,600 light-years across. The sheer brightness of such an early galaxy was a shocker. Some of the scientists involved basically said, how on earth can nature make such a bright, massive, and large galaxy in less than 300 million years? And it's not the only one. The JWST Advanced Deep Extragalactic Survey, JADES, found hundreds of possible galaxies from the first 650 million years after the Big Bang. Then, just this year, in 2025, the telescope is credited with spotting a galaxy nicknamed MOMz14. This one seems to have popped into existence just 280 million years after the Big Bang, pushing the boundaries even further back than JADES MOMz14. These galaxies aren't just surprisingly bright, There are a lot of them. JWST has shown that massive galaxies were way more common in the early universe than we thought. Astronomers using Webb also found 3 supermassive galaxies, nearly as big as our own Milky Way, already hanging out within the first billion years. They've even nicknamed them red monsters because they're so dusty. And get this, another baffling discovery is a massive spiral galaxy called the Great Wheel, about the size of the Milky Way, that formed just 2 billion years after the Big Bang. These aren't the shy little structures we were looking for. These are cosmic heavyweights already blazing with the light of billions of stars, already packed with significant amounts of dust and even heavier elements like oxygen. Oxygen was detected in Jade's JWST. Finding oxygen so early is a huge surprise because it means multiple generations of massive stars had already lived and died, spreading these elements around. That implies an incredibly fast cycle of star birth and death, way faster than we thought possible. One scientist said finding such a mature galaxy so early is like finding a teenager where you'd only expect to see babies. These discoveries aren't just little tweaks to the old model, they're punching holes right through its foundations. So, the fact that these impossibly early and impossibly massive galaxies are out there throws a giant cosmic wrench into our standard theories. That quiet flicker idea simply can't explain them. How could such huge structures pop up so quickly? How could stars ignite, live, die, and create heavy elements in such a short amount of time? These are the questions that are sending scientists scrambling back to the drawing board. The implications are massive. First off, it suggests that the conditions in the very early universe were way more friendly to rapid galaxy formation than we ever dreamed. Maybe the initial seeds of galaxies, these dark matter halos, were bigger or grew faster. Or perhaps the conversion of gas into stars happened at some crazy, unprecedented rate, like an explosive burst of creation instead of a slow burn. As one researcher put it, maybe the things that usually slow down star formation today just hadn't kicked in back then, letting some early galaxies get enormous. Secondly, it makes us question everything we thought we knew about how galaxies evolve. Seeing well-defined structures like spiral arms in galaxies like the Great Wheel so early on is just baffling. We thought those features took billions of years to develop through slow evolution and mergers. Seeing them early might mean that galactic structures can form through more dynamic, maybe even more violent processes than we currently have in our models, perhaps through rapid mergers or by quickly sucking in cold gas. The sheer number of dusty, red monster galaxies also points to a very different early environment, one where dust, a byproduct of stars living and dying, piled up much faster than expected. And this isn't just about galaxies. It touches on the fundamental building blocks of the cosmos. The rapid growth of these galaxies might even tell us something new about the nature of dark matter or dark energy, or perhaps even about the initial conditions set by the Big Bang itself. Some scientists have described the situation as a tension between theory and observation, which is a very polite way of saying the universe is showing us something fundamentally new. The phrase rewriting textbooks isn't an exaggeration here. JWST's findings are forcing a complete rethink of the universe's earliest years. The dawn of everything wasn't a quiet whisper, it was a roar, an explosive era of cosmic giants stamping their mark on the young universe. We are genuinely standing on the edge of a brand new understanding of the cosmos. In just a few short years, the James Webb Space Telescope has absolutely shattered ideas we've held for ages, and opened up completely new paths for research. This problem of these early massive galaxies isn't a crisis, it's an absolutely thrilling opportunity. It tells us that the universe is more complex, more dynamic, and honestly, way more surprising than our models ever gave it credit for. Scientists are now working like crazy to come up with new theories that can actually explain these discoveries. They're looking into scenarios where galaxies form much more efficiently, where stars ignite in more intense bursts, and where the chemical enrichment of the universe happens on fast forward. That whole idea of an explosive era of cosmic giants is shifting from a wild what-if to a scenario that the data seems to be backing up more and more. Finding significant amounts of oxygen in galaxies like Jade's JWST, existing when the universe was less than 300 million years old, is a huge clue. It shows that the processes forming stars and cooking up heavier elements were surprisingly quick and efficient. This chemical maturity so early on is key evidence suggesting that the universe's infancy was far more active and productive than that quiet flicker model ever described. These early giants weren't just big, they were already building the stuff needed for future generations of stars, and eventually planets. And it's not just about early galaxies. JWST is also uncovering other unexplained cosmic puzzles, from rogue worlds drifting alone without a star, to new details about the atmospheres of planets orbiting other stars. It's hinting at a universe just teeming with processes we're only just starting to figure out. Each new image, each new spectrum it sends back, brings fresh puzzles and deeper insights. The consistent discovery of galaxies that are too massive, too soon, or too mature, too early, just hammers home the point that our old timeline of cosmic evolution needs a major rewrite. The universe, it seems, was in a real hurry. The universe that the James Webb Space Telescope is showing us? It's not the one we thought we knew. It's wilder, more vibrant, and capable of building absolutely monumental structures with astonishing speed. These jaw-dropping secrets, these ancient massive galaxies are forcing us to face the limits of what we currently understand, and to embrace that beautiful confusion that comes with real discovery. We are literally witnessing cosmic history being rewritten page by page, image by image. The era of cosmic giants wasn't some gentle awakening, it was an explosive, brilliant dawn. What other wonders, what other paradigm-shattering secrets are still out there, hidden in the depths of space and time, just waiting for JWST to find them? We are truly living in a golden age of astronomical discovery. If these revelations about our universe have sparked your curiosity, make sure you subscribe and hit that notification bell. We'll be bringing you all the latest on what the Webb telescope unleashes next. And hey, let us know in the comments below, what JWST discovery has blown your mind the most? Thanks for watching, and keep looking up. That's all for this cosmic dispatch from Cosmic Chronicler. Don't forget to keep your eyes on the stars and your mind open to the wonders they hold. Until our next journey together, stay curious.